Welcome to Precalculus Concept 16b, rational functions and their graph. We're going to learn how to use arrow notation today. But before we can learn and talk about arrow notation, I want to talk to you guys about the most basic rational function. So we have 4 boxes, and so let's get going here. Box number 1 is, like I said, the most basic rational function that we could possibly have. It is the function 1 over x, where everything still applies. This is still the p of x right at the top, and this is still the q of x on the bottom. It's still a polynomial divided by a polynomial. The graph is very, very important to tie to the equation. You'll notice the domain of this thing will be all real numbers x, such that x is not equal to the number 0 in set notation, because if I plugged a 0 in there, I would get a 0 in the denominator. So I want you to take note of the shape of this graph. Sometimes I call this the Hurley graph. If you know the Hurley Surf Company, it kind of looks like this, you know, like the Hurley graph with 2 of these taken away, or however you want to think about it. But I want you to understand the basic shape and then the graph and how they are related to each other. Okay, so this is what the graph's going to look like, and this is the most basic of rational functions. What we're going to talk about is arrow notation, like how to describe x points on this graph as we look all around the graph, and that's what this lesson is all about. Okay, box 2 is all about how to read and to use arrow notation. Now that I look at this, this is kind of a busy graph, or busy box number 2. So let's break this down. So let's look at just stuff over here on the right hand side inside this purple box for now. What I really want you guys to understand is how to look at this and read this. This says x, and then there's a little arrow to the right, and then there is an a, and then there's a little tiny positive sign up top there. The way that we read this is as following, is as x approaches a from the right. So as x approaches the number a, whatever it happens to be, and the positive sign means from the right. Okay? So if I have this one down here, this means as x approaches a from the left, because there was a minus sign up there in the top right hand corner. That's from the left. This one down here says this is as x approaches positive infinity. So as x values get really, really big, positive infinity. And then this one over here says as x approaches negative infinity, or as x gets really, really, really small. Okay, let's now shift our attention to this part of box number 2, and I'm going to show you where these things are used. So let's take a look at this upper left-hand corner. This says as x approaches 0 from the left. The function f of x approaches what? So our goal is to be able to fill in this yellow little highlighted part here. So let's figure out what's going on here. Here's the number 0 on the x-axis, and let's say that I am over here and I am approaching 0 from the left-hand side. So as I approach 0 from the left-hand side, you'll notice that the graph seems to be doing what? It seems to be getting smaller and smaller and smaller and smaller. So the closer that x gets to 0 from the left, the graph, or f of x, or all of the y values, approach negative infinity, because they are going straight down to negative infinity. Let's take a look at this one. As x approaches 0 from the right. So if I'm on the right-hand side of 0, and I am bouncing towards 0 from the right-hand side, the graph, you can see, is getting larger and larger and larger, and then shoots up to positive infinity. So this answer is positive infinity. Down here in the lower left, as x approaches negative infinity. So if I am on the x-axis and I am approaching negative infinity, the graph is coming up with me and approaching the value of 0. It's getting closer and closer to a y value of 0. And then similarly, as x approaches positive infinity, as values get bigger, my graph, or my function, is approaching the line y equals 0. So that's going to be 0 for that one. So this is very challenging for students to understand for some reason, and we're going to do a lot of practice to try and get this down, but this is the basics of arrow notation. Okay, here's box number 3. We're going to do this example together. So notice I have a graph, I have a picture, and I want to answer these 4 questions. So we'll start with number 1. This says, as x approaches the number 3 from the right, f of x does what? So our question is, what's going on with the graph as we get close to the number 3 from the right-hand side. So let's identify where 3 is. It's right here. Okay, and then if I'm from the right, I'm going to bounce towards the number 3 from the right-hand side. The graph then looks like every time I move left on the x-axis, my function gets bigger and bigger and bigger and bigger. So, to answer this question properly, as x approaches 3 from the right, the function f of x, or the y values, or the red part of the graph, approaches positive infinity because it goes up and up and up without bound. Okay, let's see here. As x approaches 3 from the left, well, let's identify where 3 is. Here it is. If I'm on the left-hand side and I am bouncing towards the 3 from the left-hand side, my function is getting smaller and smaller and smaller and smaller and smaller. So this is approaching negative infinity. Okay, as x approaches positive infinity, so as x values go to positive infinity, my graph becomes closer and closer to the value of 0. And as x approaches negative infinity, so as my x values go to negative infinity, my graph, my function, my red part, approaches 0. So for now, a lot of times the answers are going to be positive infinity, negative infinity, or 0. But until we start moving this graph around, that's when we'll be able to see other values besides this. So these are the basics right here. Okay, box number 4 is a you try, all right? I just want you to answer this one question here. As x approaches the number -5 on the x-axis, from the right-hand side, what does the graph do? What does the function do? What does the y values do? So try and answer this one on your own. Hopefully you got the right answer of positive infinity, and here's how you do it. So as x approaches -5, so let's figure out where -5 is on the x-axis, and let's approach it from the right-hand side. So let's go bouncing towards the -5 from the right-hand side. Every time I bounce left, my graph or my function gets bigger and bigger and bigger and bigger. So this thing is shooting up to positive infinity. Hopefully that makes sense to you. We'll do more practice in class tomorrow.